Hello, this is Dr. Beck, and this is another in the series of GCSE Chemistry videos. Today's video is a review of covalent bonding. Let's start by looking at a past paper question. Hopefully you can see on the screen the question, or at least part of the question. Let's have a look how we're going to answer this. So it says fluorine has a mass number of 19 and an atomic number of 9. And we're asked to draw a diagram to show the electronic structure. So the electronic structure is going to be really important here. Now we're given two bits of information, the mass number of 19 and an atomic number of 9. How can we use this information? The mass number, as we know, tells us the number of neutral neutrons and positive protons. Doesn't tell us much about the electrons yet. However, this next number, the number 9, this is what's called the atomic number and is the number of positive protons. So maybe we can use that information. We should also be aware that for any atom, the number of protons and electrons will be the same. Every atom is neutral, has no charge. Those charges cancel out. So that's going to be very useful. We therefore know that the number of electrons for this atom, for this particular element, is 9. 9 electrons. Good. We're going to be asked now to draw the electronic structure for fluorine. Now, two ways we can do this. They're both the same, but we can put a dot in the middle, and we're going to draw these shells around. Now, how many shells do we need? Well, let's do them one by one. We know for the first electron shell, there are 2 electrons, then it's full, and then we have the rest in this second one. In this case, the rest will be 7. Okay, anywhere will do. We usually pair them up. It doesn't need to be. We could also, and this is something we also see, write the letter F to signify fluorine, and then just the same thing as before, just the electron structures. We're not worried about the protons and neutrons. We're not asked to draw those, just the electronic structure. Excellent. Let's move on to one, and then you can try that yourself. Here is our next question, very similar. So in a minute, I'm going to ask you to pause the video and have a look at this question. Try to draw this by yourself. So pause the video, come back when you're ready. Okay, hopefully you use the clues from the first one. The information we need is the information here, this atomic number of 8. We said before that is the number of protons. However, it is also for an atom the number of electrons. So we have for an oxygen atom 8 electrons. And we're asked to draw the electronic structure. Nice and simple now. We have our central dot or nucleus. In this case, I'm going to draw an O instead. And then we have our first shell of electrons, 1, 2. How many will go into the second shell? Well, it won't be full, but the others will go into this. And again, we can draw them anywhere. Usually we draw them paired, so long as we have the correct structure. We can actually summarize this as O, 2, 6. There we go. Excellent. Give yourself a tick if you got that right. Another question, is slightly different this one. So when you're ready, you can pause the video and come back to me when you've done. Pause the video. Okay, hopefully you're not finding these too difficult. This one is slightly different. We're asked to draw, but this time we're asked only the outer shell. Okay, so We know now there must be 7 electrons. That's the atomic number. And once again, we can draw a central N to identify it, and then just the outer shell. These electrons, we're going to have 2, then the rest, 5. So this is the number we are going to need to be working with. So here we go. 2, we're not going to bother showing those, we're not asked to. 5, 1, 2. You can put these anywhere. 3, 4, 5. And that'll do. N, and then just the 5 of the outer shell of electrons. Fantastic. Give yourself a tick if you got that right. Okay, so today was a chance for review of covalent bonding. We've started the process. We're looking at electrons, and that's really important for covalent bonding, because covalent bonding means sharing electrons between atoms. And I'm going to take you through some past paper questions, and you can draw the diagrams in your book or on your piece of paper. Sorry, beg your pardon, sharing electrons between atoms. Okay, let's have a look at our first example, and we're going to go through the rules of how we do this as well. So here we have a past paper question. It's worth 2 marks. It says a fluorine atom has 7 electrons in the outer shell. The diagram below shows part of a dot and cross diagram to represent a molecule of fluorine. And here we've got F2. You'll always be told this. Complete it. You should show only the electrons in the outer shell. Well, let's have a look at how we're going to do this. Here from our booklet is our list of instructions. Write down the chemical formula. Well, we don't need to, because we've got it here. Write down what atoms you need and how many. Well, again, for this, we've been given a big clue. We've got fluorine, and there are 2 atoms. Now, the exam paper has already done step 3, is drawn those atoms, but just the outer shell. Work out the number of electrons which would need to be shared, which is the same as the number of electrons which are missing. It tells you, look how useful this is. It has 7 in its outer shell. So let's fill one of these in. 1, 2, 3, 4. This needs 8. It's got 1 missing. Let's have a look at step 4. Work out the number of electrons which need to be shared. That's the same as the number of electrons which are missing. We've got 7. We need to share 1 pair of electrons, and we can show that by putting them in that intersect. Okay, let's do the same for the second atom. We're going to draw a different symbol for the electrons. They're just electrons. 1, 2, 3, and 4. 5, 6. And the 7th could go in that intersect shared by these 2 fluorine atoms. Okay, let's count now. This one now has a total of 1, 2, 3, 4, 5, 6, 7, 8. And the second one has another total of 8. I suggest that this is a correct diagram. So we'll just check the mark scheme. Let's go over here to the right. Here is the mark scheme for question 1. It looks very similar to ours. 1 shared pair of electrons anywhere in the overlap, and this is the overlap here in the middle. Or you can put this on the intersection. You could also put them at this point on the intersection. You mustn't forget the other electrons in that outer shell. We have to, for the second mark, put the 6 electrons that there would be on the outer shell. If we draw inner shell electrons, they will be ignored. You won't get marked down, but there's no point. You're not asked to do that. Let's go back to ours. I think we got ourselves 2 marks here. Okay, great stuff. Let's have a look at question 2. And let's see what we think. Here is a question about hydrogen chloride, and we have information there. To help us, I'm just going to pull down the list of instructions. I'm going to leave this on the screen here. When you're ready, stop the video and come back to it when you think you've finished this. So start the video now, please. Okay, great. So we have hydrogen chloride, and this is our atoms. These are our atoms of these things. So steps 1, 2, and 3, they've already been done for us. That's fine. That's great. Work out the number of electrons that would need to be shared. Well, how do we do this? We need to do a little bit of thinking. 17 electrons. We're asked only for the outer electron shells. So therefore 2, 8, 7 for chlorine, a group 7 element. So let's start with these. We could choose dots or crosses. I'm going to go for crosses. However, it's got one missing. It needs 8. It's going to have to share one pair of electrons. So we can put one there, and this is the hydrogen's electron. There's a different symbol to show that. Again, we check. Hydrogen has 2 electrons in its first shell. Fantastic, that's now full. The atom is stable. The chlorine has now got a total of 8 from sharing that pair with hydrogen. So I think we're about right. Let's have a look at the mark scheme. 1 mark for one shared pair of electrons. 1 hydrogen electron and 7 chlorine electrons drawn on the outer shells. Great, we have scored 2 marks. Good stuff. Hopefully now you're finding this a little bit easier. This one is a bit tougher, a little bit tougher. Again, I'll drag down the instructions. Here we are asked about oxygen difluoride. A little bit tougher, this one, but have a go. When you're ready, come back. So please now pause the video. Right, now we've got something slightly more difficult. Hopefully it wasn't too difficult. We've got oxygen difluoride. We're going to need 2 fluorine atoms and 1 oxygen. We didn't need to work that out because it's shown in the picture. However, what are we going to do? Let's start with the fluorines. If you look in your periodic table, you will see this for fluorine. This atomic number is the one we want. This tells us it has 9 electrons, and they will be arranged in the shells in the structure 2, then 7. Each fluorine will need to share one pair of electrons with another atom, and therefore form a covalent bond. So let's draw the 7. 2, 3, 4, 5, 6, 7. So it's going to share with the oxygen. And the other fluorine is going to do exactly the same. It also has 7 electrons in its outer shell, and it will need to share one pair to have then a full outer shell and form a covalent bond. So here we go. Right. Is this ready? Is this done? Well, have a look. Look at the oxygen. This has only got 6 electrons. Again, if we look in our periodic table, you see this for oxygen. This tells us it has 8 electrons, and there will be 2 in the first shell and 6 in the final shell. 6 of its own electrons, 6 of these circles. At the moment there's only 4, so we need to add 2. Here we go. 1, 2. And let's check. Fluorine 1, 2, 3, 4, 5, 6, 7, 8. Fluorine 1, 2, 3, 4, 5, 6, 7, 8. Oxygen 1, 2, 3, 4, 5, 6, 7, 8. Fantastic. Let's check the mark scheme. This is worth 2 marks. And here it is. 1 mark for 2 shared pairs of electrons. So both of these will be needed. And the outer shells are complete. Brilliant. 2 marks to us. Let's do 2 more. Hopefully by now you're seeing how it works. Hopefully by now you're getting these right. So once again, it's a chance for you now to read the question, Pause the video when you're ready and come back to it when you're finished. You will need your periodic table. Okay, that periodic table, so useful. Here are the symbols for hydrogen and for oxygen. Hydrogen only has 1 electron. Oxygen has 8 electrons, and they're arranged 2 and then 6. This is a little bit like the previous example. So hydrogen has 1 electron. It's going to have to share that to form a bond. We can show that with this. Same for the other one. Okay. I'm going to say that the circles belong to the oxygen. Those are the oxygen's electrons. Now, how many does it have in its outer shell? It has 6. It's got 2 already. I'm going to put the other 4 in pairs. We don't have to, but why not? Pairs are more useful. And there we go. 6 circles and 2 crosses, 1 each for the hydrogen atoms. We count, and we have 1, 2, 3, 4, 5, 6, 7, 8 for the oxygen, and 2 each for the hydrogens. I think that's going to be a good answer. There's a second part, which hopefully you also did. What kind of bonding is this? Hopefully you're shouting at the screen right now. This is covalent bonding. Not ionic, not anything else, covalent bonding. Again, we'll check the mark scheme. Slightly different mark scheme this time. 2 bonding pairs, yeah, that's fine. And 4 unbonded electrons around the oxygen. There's no picture here. We need to read this carefully. And the third part was covalent. So we have 2 bonding pairs. 1 bonding pair is here. The other one is over here. And then we have 4 unbonded electrons. Well, here they are. 1, 2, 3, 4. Great stuff. 2 marks. And this is also correct. Okay, last one. If you know this, if you get this, then this is getting towards that very highest grade. This is now about ammonia. And again, it's giving you lots of information, lots of details, lots of clues. Again, you will need your periodic table. So please get that and pause the video when you're ready. Okay, bit more difficult this one, bit more difficult. However, we can do it. Here is the atomic symbol, elemental symbol for nitrogen, and again for hydrogen. There we go. Let's focus on the hydrogens. The hydrogens only have 1 electron. They're going to need to share with nitrogen. Same for this one, and the same for this one. Fine. That's sorted out the hydrogens. However, what about these nitrogens? This tells us there are 7 electrons, and they will be arranged in the structure 2, 5. Oops. We've already drawn 3 of these, the circles, 1, 2, 3. We're going to need to draw 2 more. We generally put them somewhere up here, using the crosses. Okay, so 1, 2, 3, 4, 5 crosses belonging to the nitrogen, and 1 each for the hydrogens. Let's check. Well, here we've got a bonded pair. We've got another bonded pair, and each of these outer shells is now full of electrons. So I suggest this is going to be worth 2 marks. Let's just check the mark scheme. Excellent. Okay, these are slightly small, but let's just zoom in a little bit. They have chosen to put them on this, what they call the intersection. It doesn't matter. We can add these in here. It doesn't matter as long as they're within that area. Okay, anywhere within the area or on this intersection is great. So there we go. How do we mark this? 3 bonded pairs will get us 1 mark. And we mustn't forget these unbonded electrons on the nitrogen. They don't all need to be involved in covalent bonds. We mustn't forget to fill up the outer shell of the nitrogen. So there we go. 2 marks. And hopefully by now you have a good understanding of what happens in small molecules when we have covalent bonding. Remember, covalent bonding is sharing of electrons between atoms. So I hope you found the video useful. Thank you very much for watching.